Here we are back again for day 1 of Advent Code 2025 in MIPS assembly for the PS2. Let's get started, and we'll skip most of the fluff here. Essentially there's a password and there's a dial. It's a combination lock that goes numbers 1 through 99 in order. You get a list of numbers that start with an L or an R for turning left or right, and for this combination we want to count the number of times the dial ends up pointing at a 0 after any set of rotations, and the dial starts at 50. So for example, in this set here, the dial starts at 50. After 3 turns it ends up pointing at 0, so that's the first. Another 3 turns it ends up pointing at 0, that's the second. 2 turns it ends up pointing at 0 again, so that's 3, and the answer is 3 in the example there. For the second part, we change the method, and regardless, any point during the turn that it touches 0 or passes 0, ends up on 0, is counted towards the password. So in this case, the first rotation starts at 50, goes left 68, passes 0, so that's the first case, ends up on 0 here, so that's the second case, passes 0 here, third, ends up on 0, fourth, ends up on 0 here, fifth, passes 0 here, sixth. So that's the answer there. And we see that my result should be 1074 and 6254. Alright, so let's go into the code here. For the rest of my template, the rest of my code, please look at the introduction video. I'm not going to go over any of that. We'll just cover the solution part here now. So at the start of the solution there is a reset and a vsync wait that I do here just to clear off any previous solution that's sitting there. We're going to take a pointer and clear out this place at ASCII num. ASCII num is a section of memory where I store the values that come in from the input and then convert them into binary, right, into a register. So we clear that out in case there is something in there. There shouldn't be, but it could be. We get my start and the end of the input. S5 is going to be setting my mode. I set that to 0. That will determine if we're turning left or right, and S4 is my dial, which starts at 50. And then we've got our input loop here, right? So I do a set less than here. If S6 is less than 7, S7, then S2 will equal 1. And so you could use this essentially to do less than or greater than and equal. Greater than or equal, right? Those two tests you can do with this set less than variable, depending on which way around you put the two registers in here, right? So, and if it's equal to 0, so if S6 is not less than S7, we go to the input loop exit. Otherwise, we load a byte out of S2. We load I load S3 with 0A, which is the value for the ASCII value for carriage return. If it's equal, S2 is equal to S3, then it's the end, well, the end of a line, and so you want to evaluate, right? Because each line is just a rotation that we're doing, right? Then if S5 is equal to 0, we go to add ASCII. if it's not, sorry, if S5 is not equal to 0, we go add ASCII. Okay. Otherwise, we're jumping here to input loop inc, and we've got the move Z here. I'm just a little bit confused here for a second. This one here, right, I see, right. So if it's not equal to 0, we go to add ASCII. If it is equal to 0, we'll follow through here and we'll do this jump, but in this branch delay slot, we'll make S5 the value of S2. We'll move S2 into S5, right? So S5 is going to hold that ASCII value of the L or the R, right? And then we'll come through again, and the next time it's not going to be 0, so we'll go into this add ASCII. In which case we load the byte from S1, or load a byte into S1 from S0. A little bit confused here. Where is S0? Where did I use S0? Up here, ASCII num, right? So I'm just adding values into ASCII num here, I believe. Right, I'll add 1 to it. So this is the pointer of how long the string is in ASCII num. It'll store the byte using that pointer, that location, and store that pointer location back into S0, to ASCII num. Oh, sorry, we put the pointer back into ASCII num first, right? And then we add that value, then we add that to the memory location of ASCII num, so we get an offset. We AND S2 with 0f, which for digits will give us the straight up digit representation. So I can't remember exactly how it is. I think it's 30 hex is the first 0 digit for in ASCII. So 31 hex is 1, 32 hex is 2, 33 hex is 3, right? So I'm clearing off that 30 part and just having 1, 2, 3, you know, ends up in there. And then we store that byte into ASCII num. And then we fall through into this input loop increment, which will add 1 to S6, which is our reading pointer, and jump back to input loop up here. Okay, now when we get to input line here, if S5 is equal to 0, if we get to this end of line point and S5 is equal to 0, I don't think this should happen, but if we do get here, then it's going to say, hey, this is the end of the line. We should increment the input loop, right? It shouldn't get here, but if we happen to increment the input loop, so I think this could happen if we have a blank line, essentially, right? If there is a blank line, then we could end up here, and S5 is 0, and so we want to increment the pointer. I could also just say jump to input loop exit or finish day, but you know, whatever, it all works. Otherwise, we're going to turn dial, which is when we're going to actually turn the dial, right? And then once we've finished with turn dial, we're going to jump to input loop increment and also set S5 back to 0. And then the final part here, input loop exit, which we'll get to once we S6 is equal to, or greater than or equal to S7, right? And then we also want to check if we need to be turning the dial, right? So we want to check if we've got a number in ASCII num If we do have a number in ASCII num, then if we don't have a number in ASCII num, if we have 0 length in ASCII num, then we will branch to finish day. Otherwise, we'll turn dial before we finish up. And finish day, we'll do a vsync, show the done message, and we're doing the controller read to see if we're stopping. So everything else will take place in this ASCII num. So let's move down to that. Everything else will take place in turn dial. So let's move down to that. We're backing up, deleting things because I'm a fool. Backing up all these registers first. We come down here. I'm going to convert the ASCII value, or that binary coded decimal sort of value, into just a single binary number. And I'm doing this the foolish way. I fix this up later, where I multiply the value by 10 every time. Right, so I've got a multiplier here. Well, I've got a multiplier here and a 10, which is going to sit into this in S3. I load, remember S0 is ASCII num, that memory address. So we load that pointer out of ASCII num, which is the length of the number we have in there. We add that offset to that memory address, which gives us the position of the ones digit. S6 is our result, I think. But we start with 0. Now, all of these, I believe all of these are quite small. All the values in this are quite small, so it ends up being a fairly simple multiplication here. But it's still the silly way of doing it, because I'm using mults when I could use bit shifts. I could just shift left for tens multiplication. Anyway, so we load the byte out of ASCII num, the ones column first, multiply it by this multiplier up here is 2, 1, right? And then we multiply that multiplier by 10 to get for the next in the loop. Subtract 1 from S1 if S1 is equal to S0. So if we have reached the pointer, the offset, the length position in ASCII num, then we branch out. We add the value in S5 to S6, so we're adding that to the total. Otherwise, and if we haven't reached the end, we loop back here, right? Because that's in that branch delay position. Then we store 0. We store double, so we're storing a 64-bit value into S0 to clear out most of it. Doesn't matter if it doesn't, like if we have a very long value in there, it doesn't actually matter if we don't clear the entire thing. All we really have to clear is the length position. But anyway, we clear out a bunch of that, that's fine. And then I move S6 into S0 just for funsies, and I load into S7 and S6 the values and the results for gold result and silver result. So just so it's easier to increment them if I need to, or each one, like depending on the results here, right? And so now we have to do like a subtract. So what I'm going to first do is go like, if this is mainly for the gold one, right? How many times do I do a full loop of the dial, right? So if the dial, right, the dial goes 0 to 99, so there are 100 positions. If the number that we get in is like 640, right, you know you're going to pass 0 6 times at least. So you can just do that division, divide it by 100, and you can get the first value to add to your goal result, right? So what I do, take 100 there, divide by 100, divide the value in S0 by 100. That remainder I add straight to S7, and then the quotient put back into S0. So for 640, you'd add 6 to S7 and then you put 40 back into S0, right? Now we've got to move the dial. So in this case we want to see which way we're going, which in L4, if we bring back from S5, which was put into the stack pointer with an offset of 40, we load that back out of the stack, and we compare it to 4C. If it's 4C, then it's a, what is it, a subtraction, so it's a left turn, I think, yeah. And otherwise it's a right turn, and which would be adding to the value in the dial. So we do a relatively simple thing here, we just add it, we add, remember S4 is the current value of the dial, we set up at the very beginning at 50, so we add it to that. If it is equal to 0, then we add, if it's equal to 0, then we jump to 0 dial, but we also do this set less than, right, so I'm using the branch delay slot here to decide, like to set less than, even if it branches. It doesn't particularly matter, right, because at 0 dial we're going to go down here anyway. Yeah, we're alright, we're fine, we are fine. Where are we again? Okay, yeah, so we're going to set that even if we branch, it doesn't matter. Right, so if it's equal to 0, then we branch to 0 dial. We're going to set less than, so if S0, if S4 is less than 100, so it would set S0 to 1, right? So if it is less than 100, then if it is less than 100, if it's not equal to 0, then it will jump to turn dial end. We don't have to do anything. If it isn't less than 0, then we subtract 100 from it. If it's now equal to 0, if S4 is now equal to 0, like so if it was exactly 100 before, we have to go to branch to 0 dial, and we also have to add 1 to S7 here, because of ended up on a 0. And then we jump to turn dial end. Right, and this is, again, this is in the branch delay slot, so right, it has to be done anyway. Okay, it's like, so if we've ended up on 0, or we've actually crossed 0 doing this addition, we have to add another one to S7. Then we go to turn dial end, and then subtraction is sort of the same thing. So if it's, well, we start with first, if it's equal to 0, we go to sub dial 2. Right, if S4 is equal to 0, if S4 is presently equal to 0, we go to sub dial 2. Set less than, if S0 is less than S4, then this will set this to 1. So if it's not equal, if it's not less than, if S0 is not less than S4, then we'll branch to sub dial 2 as well. Otherwise, we add 1 to S7, which I'm already kind of confused about why I'm doing that. Let's see. If it is equal to 0, then we're going out. If it's not, so we add another one onto there. I can kind of not explain why I'm doing that, but anyway, let's try work this out again. So, and then we subtract S0 from S4, and we put that back into S4. If it's equal to 0 at that point in time, then we branch to 0 dial. Now we check if it is less, if S4 is less than 0. If it is not equal to 0, if it is not less than 0, we go to turn dial end. Otherwise, we add 100 to it. And then we go down here into 0 dial. And if it's not equal to 0, then we go to turn dial end. So I've kind of got this fall through here, which does another check, which is kind of pointless seeing we've got the checks up here, but you know, whatever, it works. And this is where we're adding 1 to S6, which is the silver result, if we ever end up in turn dial at this point. And then we're storing those results back into silver res, gold res, and restoring the values out of the stack, and the stack pointed back to where it should be. So let's check on this again. So we branch if, so wait a second, up here we'll go back to the where we do this jump here. So this is where we do this, we jump to sub dial, right? So if S4 is equal to 0, we branch to sub dial 2. If it is less than if it is not equal to, no, if S4 is less than, sorry, wait, what way around does it go again? If S0 is less than S4, then we will branch to this one, to subdial 2. Oopsies, deletions. So if it's greater than, okay, so if S0 is greater than S4, then subtracting S0 from 4 will pass 0. And so that's why I'm adding 1 here. Or greater than or equal to, right? So if S0 is greater than or equal to S4, then subtracting S0 from S4 will pass 0 or land on 0. And so that's why I'm adding it 1 to gold here. And then we actually do the subtraction. Yeah. Okay. I think that's all of it. So let's get this running. So I'll bring up, here we are, got it on screen. Let's unpause this, and there's our result, which I believe is exactly what we want to see. We can't see it, unfortunately. Let me get this visible, shall we? Let's move, not that one, this here up a bit. There we go. You can see it up there. And that one there. Good. So as you can see, we get the result that we are after. Okay, so there's nothing really to look at in like memory or anything, so that's all for today. Very easy one to start off with. The only thing that's a little bit tricky is, you know, the fact that it goes from 0 to 99, and making sure you take that into account as you turn the dial. Alright, so the next one is going to be day 2, which will get, I think day 2 is one of the worst ones for me actually. but we'll see when we get there. Alright, see you next time.